continuing on with how important conversions are, and even how practically you can find out some information about things at your own home. We're going to talk about heating up your water heater today, and just take a little bit of investigation, see how long it takes to heat up a water heater full of water that we start out here at 60 degrees Fahrenheit. So probably if you pulled out of your tap, about 60 degrees Fahrenheit would be your normal water. And let's say we want to heat up that water to 125 degrees Fahrenheit. And we'll have an electric water heater that's a 50-gallon water heater. And most 50-gallon water heaters out there run on 220 volts of voltage, and they'll draw about 40 amps of current. Now you may not know this formula, and if you don't, it's all right. You'll get it in electricity sometime, but power that drawn is equal to the current times the voltage. And so current is in amps, so this is in amps here, this is in volts, and your answer will come out in watts. So it simply is multiplying two numbers together. We got 40 amps times 220 volts, and that turns out to be 8,800 watts of electrical power. And for the electrical resistors in your water heater, they're pretty doggone close to 100% efficient. Pretty much every watt that you burn in electricity, it heats up and heats that water. So what we got is 880 watts of power of energy per time going into your water heater. And so let's ask the question, how long will it take, and what I'm meaning is how long will it take to go from 60 degrees Fahrenheit of water full, put brand new 50 gallons of water in here into the water heater, maybe you've just installed it or something, turn on the water heater, it starts drawing 40 amps at 220 volts, putting in 880 watts of power. How long will it take until it gets up to 125 degrees Fahrenheit? So what we do is we're putting heat into the water, and as we put in heat, the temperature is rising. So we start looking at unit conversions to do this. We're wanting to know how long. So in unit conversions, you usually try to put your answer in the numerator. Well, what do we know about how long? Well, one of the things that we know is that 1 watt is equal to 1 joule per second. So since seconds is a time, let's put that in our railroad tracks. Say that 1 second let's see. Let's rearrange this here. Multiply by seconds. So 1 watt times seconds is equal to 1 joule. And that's what we'll use for our unit conversions. I'm going to come back over here. So in the numerator, 1 watt times seconds is equal to 1 joule. So I know that looks funny, but again, all we did is 1 watt is energy in joules per time, so that's a power. We multiplied by seconds on each side of the equation, and we get that 1 joule is a watt times a second. So now we want to solve for time, so we don't want the seconds to go away, so we kind of keep that in mind, and the rest of the railroad tracks will be trying to get rid of watts and joules. Well, when we're heating up water, many times we use a conversion called the calorie. And 1 calorie is equal to heating up 1 gram of water and heating it up 1 change in a degree Celsius. So what you're doing is taking 1 gram of water, heating it up 1 degree Celsius, and the amount of energy it takes to do that is equal to 1 calorie. And it turns out that 1 calorie is equal to 4.18 joules. By the way, this is not the same as the calories that you're eating. This is a small calorie. The calories you eat are actually 1,000 times bigger than this calorie. So you really input a lot of energy. But this calorie is, we take 1 gram of water, which is about 1 milliliter, because the density of water is 1 gram per milliliter. So 1 milliliter of water heated up 1 degree Celsius, and that's the definition of calorie. So looking at this, we could sit here and get rid of some of our units by saying, all right, 4.18 joules is equal to 1 calorie. And now our joules go away. And now we could also say that 1 calorie of energy is used to heat up 1 gram of water 1 change in degrees Celsius. And so now our calories can go away. And I'm going to get rid of this stuff over here so we have more room on the board. Now the next thing we can take a look at is we need to get rid of grams and our change in degrees Celsius and our wattage here. And so we say, all right, let's just pick one of them, and let's say we want to get rid of our change in degrees Celsius. Well, it turns out that one of the conversions you memorize is that 1 change in degrees Celsius is the same as changing 1.8